The surface, as we said, was fine-grained with lots of rocks in it. It took footprints very well.
3, 2, 1, 0. Liftoff on Apollo 11.
Oh boy.
July 20th, 1969, humans only had experience on one planetary body.
The moon is not a dead body.
John Keats looked at the moon one time and wondered what there was in it.
Crustal materials of the moon being pushed together, breaking, and being thrust over one another.
Get ready to embark on the journey to outer space. From the breathtaking discoveries on Mars to the mind-boggling mysteries of distant galaxies, we'll unveil the cosmic wonders that have left us in awe. Buckle up for an electrifying ride through the cosmos, where the universe's secrets await. Sputnik. The world's first artificial satellite marked the beginning of the space age. Launched by the Soviet Union on October 4, 1957, Sputnik orbited Earth, broadcasting radio pulses that were detectable on Earth. The masterminds behind Sputnik were Soviet engineers and scientists, with Sergei Korolev playing a vital role. The satellite was a metallic sphere about 23 inches in diameter, weighing 184 pounds. It completed an orbit around Earth roughly every 96 minutes. Sputnik's success had significant implications for space exploration. It demonstrated the feasibility of launching objects into space and opened the door for subsequent missions. The U.S. responded with its Explorer 1 satellite in 1958, initiating a competitive era of space exploration. It orbited for 3 weeks, transmitting valuable data on the Earth's atmosphere before its radio batteries were depleted. The mission ended when it entered the Earth's atmosphere on January 4, 1958. Explorer 1. Launched on January 31, 1958, Explorer 1 marked the United States' response to the Soviet Union's successful launch of Sputnik. Dr. James Van Allen and Dr. William H. Pickering were instrumental in the creation of Explorer 1, and Dr. Werner von Braun led the development of the Jupiter Sea launch vehicle that carried it into space. Explorer 1 made a groundbreaking discovery in space science: the detection of intense radiation belts around Earth, now known as the Van Allen radiation belts, provided crucial insights into Earth's magnetic field and its interaction with charged particles from the Sun. It revealed the potential of using artificial satellites for scientific research, leading to subsequent missions that expanded our understanding of space. Explorer 1 operated until May 23, 1958, and its legacy endures as a milestone in the exploration of outer space. Apollo 8. The first manned mission to the moon in a historic leap for humanity, Apollo 8 embarked on a groundbreaking journey to the moon on December 21, 1968. Commanded by Frank Borman with James Lovell and William Anders as the crew, Apollo 8 was the first manned mission to leave Earth's orbit, circumnavigate the moon, and return safely. The mission's primary goal was to test the lunar module and command module in the moon's orbit, a crucial step towards landing humans on the lunar surface. As the spacecraft entered lunar orbit, the crew captured the iconic Earthrise photo, showcasing our home planet rising above the lunar horizon. Apollo 8 faced challenges, including navigating uncharted territory and managing limited resources. The crew, however, persevered, and on Christmas Eve, they shared a live broadcast from lunar orbit, reading verses from the book of Genesis to a global audience.
I hope that all of you back on Earth can see what we mean when we say it's a rather foreboding.
Apollo 11. The historic mission that fulfilled President John F. Kennedy's vision of landing humans on the moon stands as a crowning achievement in space exploration. Launched on July 16, 1969, this monumental journey carried astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. Neil Armstrong's iconic words, "That's one small step for man,"
giant leap for mankind.
Echoed as he became the first person to set foot on the lunar surface on July 20th, 1969. Buzz Aldrin followed, and together they conducted experiments, collected samples, and planted the American flag. The success of Apollo 11 marked a monumentous triumph for humanity, symbolizing innovation, courage, and international collaboration. Armstrong, Aldrin, and Collins returned to Earth as heroes, leaving an indelible mark on history and sparking an enduring passion for space exploration. Apollo 13. NASA's third moon landing mission was launched on April 11, 1970. However, it became a harrowing tale of survival in space. Astronauts James Lovell, Fred Hayes, and Jack Swigert faced serious challenges when an oxygen tank erupted on April 13, 1970, endangering the entire mission. But they demonstrated exceptional problem-solving skills. They improvised a carbon dioxide removal system using available materials on the spacecraft, ensuring the safe return of the crew. The mission's famous line, "Houston, we have a problem," voiced by Lovell,
Okay, Houston, we've had a problem here.
encapsulated the urgency of the situation. The world anxiously followed the mission, witnessing the resilience and cooperation that turned a potential disaster into a triumph. Apollo 13 showcased the dedication and adaptability of astronauts in the collective efforts of NASA's teams on Earth. Despite not landing on the moon, the mission remains a testament to human ingenuity. Apollo 17.
17, final guidance release. We'll expect engine ignition at 8.9 seconds.
On December 7, 1972, Apollo 17 marked NASA's last manned mission to the moon. The crew, consisting of Commander Eugene Cernan, Command Module Pilot Ronald Evans, and Lunar Module Pilot Harrison Schmitt, ventured into the Taurus Littrow Lunar Valley. Cernan, the last person to walk on the lunar surface, etched his daughter's initials on the moon's soil, symbolizing the end of an era.
Right in this little, it's only about a 4-meter depression. Oh, wait a minute. Oh, you're on the other side of the rock.
Apollo 17 deployed the lunar roving vehicle, enabling the astronauts to cover more ground and conduct extensive experiments. Their findings, including valuable rock samples, provided crucial insights into the moon's history. Despite being NASA's final lunar mission, Apollo 17's legacy endures through its scientific contributions. As Cernan's iconic words echo through history, "We leave as we came, and God willing as we shall return, with peace and hope for all mankind." The mission concluded on December 19, 1972, and the rest was history.
A flight at Station 1 still looks like a 45-minute stop to me.
Skylab. Launched on May 14, 1973, Skylab marked NASA's first space station. Skylab's journey began with the launch of the unmanned Skylab space station, followed by crews sent through 3 manned missions. Skylab housed a variety of experiments, exploring fields like solar astronomy, Earth observation, and biomedical studies. This endeavor significantly contributed to our understanding of living and working in space. Skylab wasn't without challenges. The space station faced initial difficulties, including a heat shield deployment issue and structural damage during launch. Skylab's mission concluded on February 8, 1974, after 6 years in orbit. Unable to be reboosted by the space shuttle, Skylab's orbit eventually decayed, and it disintegrated in the atmosphere on July 11, 1979, scattering debris across the Indian Ocean and Western Australia. Viking 1 and 2. Unraveling Martian Mysteries. In 1976, Viking 1 and Viking 2 stand as monumental achievements in the exploration of Mars. These NASA missions were designed to provide comprehensive insights into the Martian environment, searching for signs of past or present life. The Viking spacecraft were equipped with a suite of instruments, including cameras, spectrometers, and samplers. These tools allowed scientists to analyze the Martian soil and atmosphere. The mission successfully captured iconic images of the Martian surface, expanding our understanding of the red planet's topography. Viking 1 and 2 also carried out biology experiments designed to detect microbial life. However, the results were inconclusive, sparking ongoing debates about the possibility of life on Mars. While the Viking missions faced challenges such as dust storms and communication issues, their overall impact has been profound. Viking 1 operated until 1982, and Viking 2 until 1980. Both were remarkable in the pursuit of planetary exploration. Challenger disaster STS-51L. The Space Shuttle Challenger debacle on January 28, 1986 marked one of the darkest days in the history of space exploration. The Challenger on mission STS-51L suddenly disintegrated just 73 seconds after liftoff. The crew, including schoolteacher Krista McAuliffe, who was set to become the first private citizen in space. It all unfolded due to the failure of an O-ring seal in one of the shuttle's solid rocket boosters, exacerbated by unusually cold temperatures on the launch day. The loss of Challenger had a profound impact on NASA and space exploration. It resulted in a temporary halt to the Space Shuttle program and a thorough examination of the technical and organizational issues that played a role in the incident. The Challenger's misfortune prompted significant changes in shuttle design, safety procedure, and the culture of NASA. Magellan. The Magellan spacecraft embarked on a groundbreaking mission to study Venus, our neighboring planet, on May 4, 1989. Named after the Portuguese explorer Ferdinand Magellan, this spacecraft utilized radar mapping to unveil the mysteries of Venus's surface, obscured by thick clouds. Magellan reached Venus on August 10, 1990, and commenced its mapping mission, capturing high-resolution radar images and compiling a detailed topographic map. The data revealed a tumultuous volcanic terrain with vast plains, highland regions, and intriguing features like large shield volcanoes. The spacecraft's mission lasted for over 4 years, providing a wealth of information about Venus's geology and surface composition. It helped scientists understand the planet's volcanic history, tectonic activity, and atmospheric conditions. Magellan's journey came to an end on October 11, 1944, as NASA initially commanded the spacecraft to enter Venus's atmosphere, concluding its mission in a blaze of glory. The legacy of Magellan lives on in the wealth of knowledge it contributed to our understanding of Venus and planetary science. Hubble Space Telescope. Launched aboard the Space Shuttle Discovery on April 24, 1990, the Hubble Space Telescope, HST, has become an iconic symbol of astronomical exploration. Named after astronomer Edwin Hubble, this telescope is celebrated for its role in capturing stunning images and advancing our understanding of the universe. Hubble orbits Earth, avoiding the distortion of the atmosphere that affects ground-based telescopes. Its sophisticated instruments have allowed astronomers to observe distant galaxies, nebulae, and other celestial phenomena with unprecedented clarity. Despite a challenging start due to a flaw in its primary mirror, which was later corrected by a servicing mission in 1993, Hubble has delivered invaluable data. It has provided insights into the age of the universe, the existence of dark energy, and the formation of galaxies. Servicing missions, conducted by space shuttles, have kept Hubble operational and upgraded its instruments, ensuring it remains at the forefront of astronomical research. Mars Pathfinder. On December 4, 1996, Mars Pathfinder marked a significant milestone in space exploration by successfully landing a rover on the surface of the Red Planet. This NASA mission aimed to study the Martian surface, climate, and geology, while also testing new technologies for future Mars missions. The spacecraft carried the Sojourner rover, a 6-wheeled robotic vehicle equipped with scientific instruments to analyze Martian rocks and soil. Sojourner, about the size of a microwave oven, transmitted data and images back to Earth, providing valuable insights into the Martian surface. The mission demonstrated the feasibility of mobile robotic exploration on Mars and paved the way for subsequent rover missions like Spirit, Opportunity, and Curiosity. Mars Pathfinder exceeded its planned mission duration, continuing to operate until September 1997. The success of this mission not only expanded our understanding of Mars, but also set the stage for future endeavors to explore the mysteries of the red planet. Cassini-Huygens. The Cassini-Huygens mission was a joint endeavor by NASA, the European Space Agency, ESA, and the Italian Space Agency, ASI, to explore the Saturnarian system. Launching on October 15, 1997, the mission comprised the Cassini orbiter, primarily studying Saturn, and the Huygens probe, designed to descend to the surface of Saturn's largest moon, Titan. Cassini, named after the Italian astronomer Giovanni Cassini, arrived at Saturn on July 1, 2004, and embarked on a series of orbits around the planet. Over its mission, Cassini provided unprecedented views of Saturn's rings, moons, and atmosphere. One of the mission's notable achievements was the discovery of liquid methane and ethane lakes on Titan, showcasing the moon's dynamic and Earth-like features. The mission also observed seasonal changes on Saturn, enhancing our understanding of the planet's atmospheric processes. Cassini continued its mission until September 15, 2017, when it intentionally plunged into Saturn's atmosphere to avoid polluting the Saturn's moons. Mars Odyssey. Paving the way for Martian exploration on April 7, 2001, the Mars Odyssey spacecraft marked a significant milestone in the exploration of the Red Planet. Named in homage to Arthur C. Clarke's 2001 A Space Odyssey, this NASA mission played a pivotal role in preparing the way for future Martian exploration. Mars Odyssey's primary objectives were to search for evidence of water and ice on Mars, serve as a relay station for other Mars missions, and study the planet's climate and geology. One of the mission's key discoveries was the confirmation of vast reservoirs of water ice beneath the surface of Mars. Odyssey's thermal emission imaging system, THEMIS, captured detailed images of the Martian surface, aiding in the selection of landing sites for subsequent missions. As a reliable communications relay, Mars Odyssey played a crucial role in supporting missions such as the Mars Exploration Rovers and the Mars Science Laboratory. New Horizons. Inaugurating a new era of exploration, NASA's New Horizons spacecraft embarked on a historic journey to unlock the mysteries of the outer solar system. Launched on January 19, 2006, New Horizons had a singular mission: to study Pluto and its moons, providing humanity with its first close-up view of this distant and enigmatic world. New Horizons conducted a flyby of Jupiter in 2007, utilizing the planet's gravity to increase its speed and fine-tune its trajectory toward Pluto. After a 9-year, 3 billion-mile voyage, the spacecraft conducted a historic flyby of Pluto on July 14, 2015, capturing detailed images and data of this distant dwarf planet and its 5 moons. The mission revealed unexpected details about Pluto's complex and varied terrain, showcasing vast icy plains, towering mountains, and a hazy atmosphere. New Horizons also continued its mission into the Kuiper Belt, providing valuable insights into the icy remnants of the early solar system. Phoenix Mars Lander. In a quest to uncover the mysteries of Mars' polar regions, NASA's Phoenix Mars Lander touched down near the planet's North Pole on May 25, 2008. This groundbreaking mission aimed to explore the Martian Arctic surface and subsurface, studying the region's geology and searching for potential signs of past or present microbial life. Equipped with a robotic arm, a suite of scientific instruments, and a laboratory, Phoenix conducted a series of experiments to analyze soil and ice samples. One notable discovery was the confirmation of water ice in the Martian subsurface, offering valuable insights into the planet's geological history and potential habitability. Phoenix's mission was relatively short-lived, concluding in November 2008 as sunlight waned during the Martian winter. Despite its limited duration, the lander provided a wealth of data, significantly advancing our understanding of Mars's polar environment. SpaceX Falcon 1. On September 28, 2008, SpaceX, the brainchild of entrepreneur Elon Musk, achieved a historic milestone with the successful launch of the Falcon 1. This marked the first privately developed liquid-fueled rocket to reach orbit, demonstrating SpaceX's capability to revolutionize space travel. Falcon 1's journey to orbit was not without challenges. The rocket faced multiple failures in its early attempts, with the first 3 launches ending in disappointment. However, the 4th launch, carrying the lightweight payload of the RatSat nanosatellite, made history by reaching Earth's orbit. The success of Falcon 1 laid the foundation for SpaceX's subsequent developments, including the Falcon 9 and Falcon Heavy rockets, and fueled the company's ambition to make space travel more accessible and cost-effective. Elon Musk's vision of reducing the cost of space launches and making interplanetary travel a reality began with the Falcon 1's triumphant ascent into orbit, marking the dawn of a new era in space exploration. SpaceX Falcon 9. In the realm of space exploration, 2010 was a landmark year with the introduction of the SpaceX Falcon 9 rocket. Developed by Elon Musk's aerospace company SpaceX, the Falcon 9 marked a significant shift by incorporating reusability into its design. Launched for the first time on June 4, 2010, the Falcon 9 was a 2-stage rocket designed to transport payloads into Earth's orbit and beyond. What set it apart was its first stage, equipped with landing legs and grid fins, allowing it to return to Earth and land vertically for refurbishment and reuse. This breakthrough in reusability was a game changer, promising to dramatically reduce the cost associated with space missions. The successful landings of Falcon 9 boosters on drone ships or ground pads became iconic moments, symbolizing the dawn of an era where rockets were discarded after a single use. The Falcon 9 has since become a workhorse for commercial satellite launches, cargo resupply missions to the International Space Station, and crewed space flights. Change E3. China made a significant leap with the Change E3 mission in 2013. Named after the Chinese moon goddess, Change E3 aimed to achieve a historic feat, soft landing a rover on the moon. It set out on December 1, 2013. The mission carried the U2 rover, meaning Jade Rabbit. The rover, equipped with a suite of scientific instruments, was designed to explore the lunar surface, analyze soil samples, and conduct various experiments. On December 14, 2013, the lander successfully touched down on the moon's northern hemisphere, becoming China's first spacecraft to achieve a soft landing on an extraterrestrial body. Shortly after, the U2 rover deployed, making China only the 3rd nation to achieve a rover-driven exploration on the lunar surface, following the United States and the Soviet Union. The success of this mission paved the way for subsequent lunar missions, including the ongoing Change E4 and upcoming Change E5. Rosetta and Fly. In 2014, the European Space Agency, ESA, achieved a historic milestone in space exploration with the Rosetta mission and its comet lander Fly. Launched in 2004, the spacecraft embarked on a 10-year journey to study comet 67P Churyumov-Gerasimenko. Arriving at the comet in August 2014, Rosetta began orbiting and studying it in unprecedented detail. The spacecraft's lander, Fly, aimed to perform the first ever soft landing on a comet's surface, offering a chance to study the primordial building blocks of our solar system. On November 12, 2014, Fly descended to the comet's surface, but its harpoons failed to anchor it to the icy terrain. Despite the setback, Fly transmitted valuable data during its initial hours of operation before entering hibernation mode due to a lack of sunlight. The Rosetta orbiter continued its observations, providing invaluable information into the comet's composition and behavior as it approached the sun. The mission officially concluded in September 2016, when Rosetta made a controlled descent to the comet's surface. Hayabusa 2. Launched by the Japan Aerospace Exploration Agency, JAXA, in 2014, the Hayabusa 2 mission set out on an ambitious journey to explore the asteroid Ryugu. This spacecraft followed in the footsteps of its predecessor, Hayabusa, which successfully returned samples from the asteroid Itokawa in 2010. Hayabusa 2, equipped with advanced scientific instruments, reached Ryugu in June 2018 after a journey of over 3 years. The mission's primary goal was to collect samples from the asteroid's surface and bring them back to Earth for analysis. In February 2019, the spacecraft made a dramatic descent to the asteroid's surface, firing a projectile to stir up and collect subsurface material. Hayabusa 2 then carefully stored these samples in a sample return capsule. The spacecraft departed Ryugu in November 2019, beginning its journey back to Earth. In December 2020, the capsule successfully re-entered Earth's atmosphere, providing scientists with pristine samples from an asteroid. SpaceX Falcon Heavy. The most powerful operational rocket in the world made its historic debut on February 6, 2018, from Kennedy Space Center's Launch Complex 39A. Founded and led by Elon Musk, SpaceX aimed to revolutionize space access with this heavy-lift rocket. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, boasting 27 engines capable of producing over 5 million pounds of thrust at liftoff. Its maiden flight carried Musk's personal Tesla Roadster as a whimsical payload, complete with a spacesuit-clad mannequin named Starman in the driver's seat. This groundbreaking launch demonstrated the feasibility of reusable rocket components, a cornerstone of SpaceX's cost-saving initiatives. The side booster successfully landed back at Cape Canaveral for refurbishment and reuse, showcasing the company's commitment to sustainable space exploration. Falcon Heavy's subsequent missions included deploying a Saudi communications satellite. Its capacity to lift heavy payloads positions Falcon Heavy as a key player in future deep space exploration and interplanetary missions, including potential crewed missions to the Moon and Mars. Chandrayaan. Chandrayaan, India's lunar exploration program, symbolizes the nation's ambitions in space exploration. Launched by the Indian Space Research Organization, ISRO, the program had its genesis with Chandrayaan-1. Chandrayaan-1, launched on October 22, 2008, was India's first mission to the Moon. Equipped with a suite of scientific instruments, including a moon impact probe, it made significant contributions to lunar science. One of its most notable discoveries was confirming the presence of water molecules on the lunar surface. In July 2019, ISRO launched Chandrayaan-2, the second lunar exploration mission. This ambitious mission included an orbiter, lander, and rover. Chandrayaan-3, the highly anticipated follow-up mission, aimed to further explore the lunar surface.
Speed down at 9. Gate forward.
Potentially with an emphasis on a successful soft landing. And just recently, it successfully landed near Moon's South Pole on August 23, 2023. India's Chandrayaan-3, the mission to the Moon's South Pole, a first of its kind, did not wake up again. Artemis. The Artemis program, led by NASA, stands as a monumental effort to return humans to the lunar surface. Building on the legacy of the Apollo missions, Artemis aims to land the next man and the first woman on the Moon by the mid-2020s. Officially initiated in 2017, Artemis involves a series of crewed missions, including Artemis 1, an uncrewed flight to test the Space Launch System (SLS) rocket, and the Orion spacecraft. The program's name pays homage to Apollo's twin sister Artemis, the Greek goddess of the moon. Beyond lunar exploration, Artemis envisions using the moon as a stepping stone for crewed missions to Mars. Artemis represents a collaborative effort, with international partnerships and the inclusions of the first woman and the next man on the lunar surface will mark historic milestones. It's time for today's open discussion. This picture shows an astronaut standing on the surface of the moon, and its surface appears to be cracked. Though it is mainly a religious claim that the moon was once split in half, The moon is covered with visible cracks all over. It is strongly believed that many of the cracks visible on the lunar surface are due to these asteroid impacts. Interestingly, these cracks are not always shallow and can extend to a depth of about 12 miles. Although nothing of this gravity has ever been documented, if this were to be true at any point, the consequences for it would be pretty devastating. The destabilization of the moon's surface could severely impact the Earth's gravitational field, meaning if the moon would blow up, there wouldn't be an Earth to look forward to. Thank you very much for watching the video. Do like and share it with your friends. Subscribe to the channel and hit the bell icon to not miss any of the upcoming amazing videos. Thank you once again.